Welcome back. Today we're going to be looking at statistics in Python. And of course statistics are very important. So the statistics library does mathematical statistics functions. And this includes functions for doing statistics with numeric data, so you can't do it with other types of data. And it's not meant to compete with NumPy or SciPy. It's just used to be there, and because it's very lightweight. For NumPy and SciPy you have to install lots and lots of libraries, whereas for using this library it comes with Python. And all the functions support int, float, decimal and fraction, which are all the data types in Python. So to start, we'll import random and we'll generate 10,000 random numbers between 1 and 100. And you can see it's done that. So you can just view a random sample of these numbers, and you can see there's these. So now we're going to use statistics, and it's a lot easier to do this without putting statistics dot at the beginning of everything, so we just import everything. So first we can print the mean and the f-mean. And so f-mean stands for floating point mean, and what that means is if you have data that's decimal or fraction or int, it converts it all to float first and then calculates the mean, and that means it's a lot quicker. And mean just calculates the mean. However, there are three types of mean. There's the arithmetic mean, the geometric mean, and the harmonic mean. And you can see we can calculate these from the data and see that the AM, GM, HM inequality holds, because this one should always be more than this one and more than this one. And so what it's done is it's taken all the numbers, added them up and divided by 10,000. Here it's taken all the numbers, multiplied them together and then taken the 10,000th root. Here it's taken all the numbers, added up the reciprocals and then taken the reciprocal of that and divided by n, and you can see that's even smaller. And these all have different uses in different contexts. We can also calculate the median of the data, and you'll see that the median is 50.0, but the median low and the median high are also 50. And what that means is when there's an even number of values, so here there are 10,000, usually when you calculate the median, you take the mean of the two middle values if you've got an even number, and that's where you've got 50.0. However, when we ask for the median low, we want the lowest of the two medians, and here we want the highest rather than the median, which is the mean. We can also find the mode of our data, and you can see the mode is 33. And if we had multiple modes, we could work out what it was, but the only mode is 33. That's the most common data. Another thing we can do is break our data into quantiles. So you can see we can break it into quantiles of 10, and there's a 91 in there because it's not perfectly uniformly distributed. And then we can break it into 20 quantiles. And notice that every other quantile in the second list is the same as the one in the list above, which is quite useful. We can also calculate standard deviation and variance. So you can see the standard deviation of our numbers is 28.96, and the variance is just the standard deviation squared. So we can do a lot of statistical things with our data. And obviously this is a toy data set. It doesn't have huge value, but you might be able to just read from a CSV and then quickly calculate all these values without worrying about using other libraries. Another thing that the statistics library can include is a normal distribution, and this is a standard normal distribution with the idea that it's got a mean of 0 and a standard deviation of 1. And we can actually create one of those, and I've left the values to be mean of 0 and standard deviation of 1. And you can see here that means that the mean is 0, the median is 0, the mode is 0, the standard deviation and variance are both 1. Because obviously if you square 1 you get 1. We can actually then create 10 samples from our data. So you can see these are 10 things generated randomly from our normal distribution. And you can see most of them are between 0 and 1. This is obviously the largest one. And we can also calculate the cumulative distribution function of sample 0. So this says that 86.2% of all the numbers it generate will be less than this value here. And that kind of makes sense because it's just past one standard deviation, and 68% of data is between those two middle standard deviations. So that seems like a reasonable estimate. We can also use this to calculate inverse cumulative distribution function. So if we use 0.84, you can see that any data being less than 0.994 has an 84% chance of happening. So this one, is 86, and that's because this number is only slightly above this number. So you can see that that's very useful. And this is quite a useful function when checking for outliers, because if there's a 0.001 chance that any data is more than that number or less than that number, then your data is probably an outlier, and so you can use this function to check it. And finally, we can break it into 10 quantiles, and you can see that these are the values it comes up with for the 10 quantiles. And because we've got 10 quantiles, that's saying 10% of data is between 0 and 0.253, and then 10% between here and here, 10% between here and here, 10% between here and here, and 10% above here. So you can see that 1 is somewhere between here, and that means that there's a point where 84% of data is less than this value appears at some point in here. You can also see that it's symmetric, which is a huge property of the normal distribution. But this is a very useful function to know, especially because almost everything follows a normal distribution. So you can see the statistics library in Python is very useful. It does a few things. It's not recommended for statisticians because it's not aimed to compete that way, but it's lightweight and comes with Python. So hopefully you've enjoyed this video. You can use the statistics library in the future, and I'll see you again same time next week. Till then.